We're going to evaluate the integral of x cubed divided by the square root of 1 minus x squared. And we're going to do it by using two different integration techniques. The first one is trigonometric substitution. Since we have square root of 1 minus x squared, our substitution is x equals to sine of theta. Differentiating, dx becomes cosine of theta d theta. Squaring both sides, x squared equals to sine squared theta, and then 1 minus x squared equals 1 minus sine squared theta, which is cosine squared theta. Now let's replace all the x's in the original integral with the equivalent functions of theta. X is sine theta, so x cubed is sine cubed theta, divided by square root 1 minus x squared is cosine squared of theta, and dx is cosine of theta d theta. Let's rewrite it. This is equal to the integral of sine cubed theta. We can take square root of cosine squared theta as cosine of theta, and then times cosine theta d theta. The cosines cancel, and we're left with the integral of sine cubed. So what we have to evaluate now is the integral of sine cubed of theta. Recall, when we have an odd power of sine or cosine, we factor or remove one of the powers of sine or cosine, in this case sine of theta, times the remaining powers, which is sine squared theta d theta. Now we're going to replace sine squared with 1 minus cosine squared by using the basic trig identity, and this gives us two integrals. The first one is sine theta times 1, so that's sine theta d theta. Then we have a minus sign, and the second integral is the integral of sine theta times cosine squared theta d theta. The first integral is easy to evaluate. The integral of sine is minus cosine of theta. For the second integral here, we're going to make a substitution. If I let u equal to cosine of theta, du is minus sine of theta d theta. So minus sine theta d theta will be replaced by du. So we have a minus sign right here. We have a sine here, and then d theta. That will be replaced with du, and cosine square will be u square. So this is now plus, because the minus sign is gone, the integral of u squared du, which is now minus cosine of theta plus 1/3 u cubed. Since u was also cosine of theta, we end up with the following as the answer in variable theta: minus cosine of theta plus 1/3 cosine cubed of theta. But recall that our original integral was in variable x, so we must have an answer in variable x. The substitution was x, let's write it as x over 1 equals to sine of theta. So we can draw a right triangle that looks like something like this. Call this angle theta, and sine is opposite divided by the hypotenuse, so we let opposite be x and the hypotenuse 1. That means by Pythagorean theorem the adjacent side is the square root of 1 minus x squared, because if we do adjacent square plus opposite square, we get the hypotenuse square. So the answer is cosine here is square root of 1 minus x squared divided by 1, and our final answer is minus the square root 1 minus x squared plus 1/3. Then we take square root of 1 minus x squared and cube it. That gives us 1 minus x squared to the 3/2 power plus constant of integration c. So that's the final answer using trigonometric substitution. Now let's evaluate this integral using a different method, just regular substitution. So here's how we're going to do that. Let's rewrite the integral. This is x cubed over the square root of 1 minus x squared dx. I'm going to let w equal to 1 minus x squared. dw is minus 2x dx, and therefore minus 1/2 dw equals x dx. But when we look at the integral, we have x cubed instead of x dx. If we just had x dx, then we would replace it with minus 1/2 dw. What do we do about x cubed in the numerator? Well, we're going to rewrite the integral as follows. X cubed can be written as x squared times x divided by the square root of 1 minus x squared dx. So x dx right here will be replaced with minus 1/2 dw. But then from this equation we can solve for x squared. So x squared equals to 1 minus w. And so the x squared that you see here will be replaced with 1 minus w. Now we can express this as the integral in variable w. X squared is 1 minus w. The x dx is minus 1/2 dw. And in the denominator we have square root of 1 minus x squared. That's the square root of w. So let's rewrite this as two separate integrals. The minus will, when we multiply the numerator by -1, it'll switch to w and the 1. So we can write it as positive 1/2 times the integral of w minus 1. In the denominator we have square root of w, which is w to the 1/2, and then dw. And this is equal to 1/2 times the integral w over w to the 1/2 is w to the 1/2 dw, minus 1/2 times the integral of w to the minus 1/2 dw. And this is equal to 1/2 times 2/3 times w to the 3/2 minus 1/2 and then w to the 1/2 over 1/2. So the 1/2s here cancel, and this is equal to, here we can cancel the 2, so we have 1/3. W, recall, is 1 minus x squared, and it's raised to the 3/2 power, and then minus w to the 1/2. That's the same as square root of w. So square root of w, which is square root of 1 minus x squared, plus the constant of integration c. When you compare it to the answer we got using trig substitution, of course it's the same. So we were able to evaluate this integral using two different methods. Sometimes that happens, not often, but